Hello, welcome to my channel, and this is going to be my second video of this channel. And in this video I'm going to discuss about designing ESP32 room or 32 custom board, where most of the people are using the ESP32 these days. So I thought about explaining simple custom board design and provide you the Gerber file and BOM at the end. So if you wish to uh, fabricate this PCB yourself, you can have the files, and I will explain each of the schematic in detail. And this video will take about 30 minutes. So let's get started. So our agenda today is, first I am going through the schematic design, which is already done and tested, and also the PCB design, which is already tested myself. And then I will generate the PCB manufacturing files, and I will add the files linked to the links in the description so you can access and fabricate the PCB. So let's get started. The design is on the KiCad. So I'm going to my KiCad. I'm going to open my KiCad design, and in the KiCad, uh, I have already designed the custom board and schematic. What I'm going to do is I'm going to explain the schematic and the PCB and provide you the files later at the end. So let's get started with the schematic first. So in this schematic, I have divided this schematic into the separate sections so we can easily understand each of the sections. Uh, First of all, I will start with the main part of this PCB, which is the ESP32 uh, module. So in ESP32 module, we have uh, input output pins and some reset pins and power supply, ground, and some pins which are internally connected to the internal memory of the module. So uh, the basic in this schematic I have for the ESP32 section, I have only added the basic required things in this schematic. Like this is very simple, this is simple design. So let's get started from the power supply side. So this module is powered by 3.3 volt, which is normally this within the range of specification of the ESP32. So 3.3 volt is very common voltage for ESP32 applications. And we have two capacitors. Uh, one is to reduce digital noise, and one is to uh, stabilize the power whenever there is a high current demand. This capacitor can support the module rather than expecting it from the power supply, which can lead, like whenever we have bigger capacitor like the 10 microfarad, it supports the module when there is a demand for the power, like a very peak demand. Whenever there is a high demand coming very quickly, this capacitor can support. So normally these two values are suggested by ESP manufacturers. So I have used the value suggested in the datasheet. So next thing is the reset side circuit. So I will, okay, let's go to the ground connection. So ground is directly connected to the common ground of the schematic. Now let's go to the reset side of the circuit. So in the reset side, uh, we have the enable pin. This enable pin should be uh, held high. Otherwise, if we put this enable pin to low, this will reset the module, like restart the module. So normally we should hold this pin high, otherwise module will not start. So for that I have put 100k uh, resistor, and ESP32 datasheet suggests using um, 10K with 1 microfarad or 100K with zero point 0.1 microfarad. Like the RC time constant of these two combination should match their specification. So normally you can use either 10K with 1 microfarad or 100K with zero point 0.1 microfarad as I have used here. So the reason I used a zero point 0.1 microfarad here with 100K is because I am having zero point 0.1 microfarad here, and so that I can reduce some cost in the BOM whenever we are using the same capacitors everywhere, which will slightly reduce the cost, not much. Anyway, okay, now here we have a push switch, a tactile button in the PCB, which we can push this button and put this enable pin to low so that user can reset the module. And now let's go into the more other pin, which is very important, which is the IO0. Most of the ESP32 modules, IO0 pin is the boot, but in some modules, IO9 and some different pins are the boot pin. So what does this boot pin do? So normally we have to hold this boot pin high in order to module to boot into normal mode. In the normal mode, what will happen is the module will turn on and it will execute the program we have downloaded to the module. What happened in these if we put this IO0 pin to low whenever module is turning on? Just keep remember, whenever if you press and hold this button, it will held this IO pin to low because the other side of this button is like the switch is connected to the ground. So if someone press and hold this a button while module is turning on, the module check the status of the reading of the IO0 pin, and if it is low, it goes into the download mode. Like in download mode, we can download the program to the module. But if it is whenever the module is booting up, if this IO0 pin is held high, which means this button is not pressed, in that case, module goes to the normal mode and execute the program we have already downloaded to the module. So these are two modes of ESP32. So we can use this push switch to switch between download mode and normal mode. So that is the purpose of this switch. So we have two switches in the circuit, which one is reset and one is boot switch. I will name this as boot switch. Okay, let's move into the other things. So uh, all of the other IO pins are mapped into two IO headers here. So those are directly connected to the these headers. But keep in mind that some of these IO pins are strapping pins, which means uh, if you held some of pins high or low while module is booting on, the module will not boot successfully. This is one thing. If you are do you have to keep in remember if you are designing a custom PCB with ESP32. In my case, I have directly connected to two jump through the header, so there is no impact on the status of these pins. Like the header will not force them high or low, so that the booting will happen normally. But if you are connecting some peripherals to headers, that might cause uh, some boot fails if you are using strapping pins. So you have to read the datasheet and understand about the strapping pins. I am not going to explain the strapping pins here because it will take long. Okay, now let's move into the programming side. So in the ESP32, to program, I have added a Type C connector. So in this Type C connector, we are using the same connector for the power and also the programming. Let's discuss about the programming first. So for the Type C connector, you need 5.1 kilo ohm resistors to act as it as a slave board. I mean, not a host. This is a slave device, so we need to add 5.1 uh, k resistors for these CC pins. Then the data lines are combined from the data lines are going to CH340C. The version C indicate that we don't need the external oscillator. Some of CH340, for example, G need the external oscillator. I use C, so it makes my design very simplified. So data pins, the USB interface coming through the USB interface of this IC, this chip. This is a USB to UART bridge. So TXD and RXD pins going directly to the like TXD of the chip, this CH340 chip going to the RXD of the ESP32, and RXD go to the TXD of the ESP32. And these two capacitors, as I previously explained with the ESP32, to stabilize and reduce the noise coming from these VCC and V3 pins of the chip. And DTR and RTS signals, we can effectively use these two signals to reset the module and held IO0 low. So what happened is, for example, let's say you are giving the command uh, through the Arduino, for example. You are trying to download the program to the module. So one way is we can, as I explained here, we can manually put the module to the boot mode. How we can do that? We can press and hold this IO button, and we can press the reset button and release. So what happen is, whenever you press the reset button, it will restart the module. So since you are pressing and holding this button, whenever it is restarting, it sees IO0 as low state, so that module will boot into the download mode. Then you can use this RxD and TXD pins so that you can download the program. You can directly send the program using RxD and TXD pins through a USB to your bridge. But this is doing this like pushing this and holding this and pushing the reset button, which is kind of manual work we don't want to do. So if there is someone who can do this, it is much better. So this CH340 IC provide DTR and RTS output, which we can effectively use for to reset and hold the IO0 pin low using this combination of the transistors. I am using a combined chip which have inbuilt two transistors, so it make things very easier. So this is called auto reset, auto flash circuit. You can find this similar circuit in other boards, like for example some from Spark One and other ma- other board uh, creators. Okay, now let's move into the I think power part. So power side, so we have a power supply which is 3.3 volt simple LDO, like a linear voltage regulator. It is always enabled using this enable pin, and V in coming through this power supply, Here is stabilized capacitors for the input side, and the output side we have another capacitor. So these are recommended values from the data sheet of this chip, and it is very simple design, and this is I hope you can understand. But here we this is one thing we have to talk about. So this board can be powered either using a battery, a lithium ion battery like 3.7 volt battery, or either from USB. So how this circuit works? So normally if we are using battery, we want to charge the battery and we want to save the power whenever USB is available. So what happen is uh, the battery is connected through a PMOS, P-channel MOSFET here, and normally let's say in a first a scenario, let's discuss about the scenario where VBus is not presented. So once VBus is not presented, which means there is no voltage in this VBus coming from here, so it's can be s- so it is floating, but since it is grounded through 100k resistor here, this line becomes zero since it is held low through this resistor. So gate is in zero, but battery voltage is 3.7 volt. So I will try to explain using illustration. So here we have 3.7 volt, and through this diode here, this 3.3 volt is uh, plugged into the this source of the p-channel MOSFET. So what happen is um, in a p-channel MOSFET, now this is 0 volt, and now this is again around 3.7 volt, and since now source to gate voltage is minus 3.7 volt, if we measure voltage of the gate respective to the source, we can consider the gate voltage as minus 3.7 volt, which means minus 7 or 3.7 volt will activate p channel MOSFET, so that this p channel MOSFET is activated, and this p channel MOSFET is very low in resistance, so it will provide the current path from battery to power supply through this MOSFET. Okay, so this MOSFET will start to conduct and supply the power to this LDO, and LDO will convert 3.7 volt to 3.3 volt. Okay, now let's assume a case where VBus is presented. Now uh, again I will illustrate using this simple screenshot tool. So here we have 3.7 volt. Here now we have 5 volts coming from USB. Now gate is at 5 volt, and this diode start to conduct, and this diode start to conduct, and with a drop of the voltage on the diode, this uh, voltage will be around, let's say, 4.4 volt. Now you can see here voltage is the voltage here is higher than the battery voltage, so this MOSFET will not conduct. Even though it conducts, still gate voltage is higher than the source voltage, so that this MOSFET will not activated. It will also this 5 volt and coming from this diode, and will not flow back to the battery because this MOSFET is not conducting, and this diode is also in the body diode is also in the reverse direction. So what happen is for the 5 volt coming from this V bus will flow through the diode to V in pin, and that LDO will convert that to the 3.3 volt. If you need to save more power, you can replace this LDO with a buck converter. This circuit, but still this power selector like a power switcher will remain same. Okay, in this when you are selecting this diode and this MOSFET, you should consider about the current rating of the, for example, current rating and the turn on resistance. The resistance would be very low to reduce, to save the loss. I mean, reduce the loss, and the current rating should be high enough, otherwise this MOSFET will be damaged. Same applies to the diode. You should use a Schottky diode, like a low drop diode with a good, better current rating, sufficient current rating for the application. Now I am moving to the battery charging section. So now you understand that whenever VBus is connected, the battery is isolated from this circuit through this MOSFET. So what we are doing here is, whenever VBus is presented, this VBus is provided into the TP 4056 IC, which is 1 ampere, maximum 1 ampere charging current capable IC. And through this IC, we are connected the battery. For is the IC is connected to the battery. So we can regulate the charging current using the value, like we can program charging current using this value. I am using the 1.2k, which is for 1 ampere. So if you change this value, you can reduce the, for example, if you want to reduce the charging current, you can reduce using this resistor value. And these two LEDs will show the charging status. For example, this red LED will start to turn on when no module, the battery is charging, and when it is done, the green will turn us on. And we can set these two resistor values according to the brightness you need and according to the LEDs you are using. Okay, so these capacitors are to stabilize and reduce noise. So, um, okay, so that's it about the design. So, in a summary, this design have ESP32 programming, auto flash, and battery charging capability, and 3.3 power supply, and ESP32 room itself, and header. So if you are using going to design a custom board with something, what you can do is, if you need to add more things, like for example, you want to add you want to design a GPS tracker with Wi-Fi. What we can do is, you can add a GPRS module, and connect to this IO pins. And also, if you want to add mobile connectivity, you can add the GSM module, for example, from Simcom or Telit or something like that, and connect to the module and design uh, uh, another PC. I mean, improve this design. So normally this is kind of a development board stage design. Okay, now let's move into the PCB design. I know it's quite longer than expected the video, so I'm going to the PCB and I'm going to explain the PCB design in very quickly. Since I'm providing you files for the Gerber files, you can manufacture the PCB, but what I will explain in the PCB design is so some important things you have to consider. So for example, the footprint and displacements should be very clean, and whenever you are designing a PCB, spend more time on placing the component, not the routing. Once you have placed the component better, you can route the PCB very neatly. uh, so for example, in this design, you can see the IO pins are going to the headers. uh, and from the both side. And in the antenna area, this is something I want to mention. In the antenna area in the ESP32, you should not place any copper, and I have made a cutout in the board so that antenna will otherwise if you place something like copper, what will happen is um, it will reduce the antenna performance. And here we have a battery connector and a USB connector. I will show the 3D view so that you will understand. So I hope uh, the schematic explanation is the most thing important for you if you are designing a ESP32 board. But the PCB, you once you draw the schematic correctly, you can design it very easily. The PCB as you but the things you have to uh, give your attention is the antenna area for the ESP32, and for the power lines you should use a higher trace width for the power lines, but for the other data lines you can use like 8 mil or 12 mil or even 6 mil traces. And I have placed two reset and one reset button and boot button here. This is the UART to USB bridge, and the auto reset circuit is here. And this is the battery charge IC, and this is the voltage regulator. And this the diode and this MOSFET are the power selector. They can select either, they can take power either from battery or from the USB. So these are the two status, battery status, like charging status. It will those are connected to this battery charging IC. Okay, this is the bottom side of the PCB. So I hope this video will be very informative for you if you are you design. Also, one more thing I want to mention here: the capacitor I mentioned for the stabilize the power for the ESP32 should be placed very close to the power input pin of the ESP32. So that is very important. And that's it. Yeah. Mm, if you have any question, you can write down in the comment section, so I will answer. And if you need further support or something like that related to any circuit design, you can contact me, or you can uh, type a comment so that I will reach you out. Thank you so much for watching my videos, and uh, wish you good luck with your electronics engineering journey.